All right, guys. So we talked a bit about the p-value. You watched the video on the p-value. The p-value is going to be so critical, guys, that every single problem is going to be we're going to decide whether we support a claim or we don't support a claim based on the p-value. So you will see, we will put the p-value into practice today. I talked about the tests yesterday, that there were three types of tests. One is called the right tail test, something that looks like this. So if this is a greater than, guys, this is a right tail test. Then I showed you an example of a left tail test when you see something like that. When this is a less than, then we have what we call the left tail test. And then a two tail test, guys, it's different from. When you see something like that, this is two tail test, different from. There will be some very simple questions in the homework online. It will give you something like that and ask you, what does it represent, a left, right, or two tail test? Well, since you see the alternative is less than, you say it's a left tail test. And this is a two tailed test. All right. That's something I touched on yesterday. Then we did this example and we decided which one is left, right, or two-tail test. I'm just gonna do it again quickly. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So P is 61%, guys, and not equal here, and equal 61%. And since you see equal, not equal, you know this is a two-tailed test. The second one, a car dealership announced that the mean time for oil change is less than 15 minutes, where the less than goes to the alternative, and your null will be greater than or equal to 15. Again, to check if this is left, right, or tailed, you don't look at the null, you look at the alternative. This is a less than, that means it's a left. Next one. A company advertises that the mean life of its furnaces is more than 18 years. The more than should be in the alternative. And the complement of this will be less than 18 years. And you see, guys, this is more than, that means this is a right tail test. Now, how we're gonna make decision based on the p-value? We're gonna compare p-value with the level of significance. The level of significance, I told you yesterday, it's a probability, maximum allowable probability of making a type 1 error. What is a type 1 error? It's when you reject the null hypothesis when it is true. Does this happen? It does happen, yes. So we'll try to minimize this, and this is what we call alpha. If your p-value turns out to be less than alpha, you end up rejecting HO. And if your p-value, guys, turns out to be more than alpha, then your decision should be fail to reject HO. Throughout the lesson today, guys, I'll be making one of two decisions. Either I reject HO or fail to reject HO. For this part, guys, I will visit later after I do some exercises and write the conclusions from the exercises here. Okay, so I'm gonna just proceed now. And then before we start the new stuff, I'm gonna go over the practice that I sent you yesterday and ask you to go over it for section 7.1. So let me just go over this one. That's what I ask you to go over. There are examples to state the null and the alternative. So practice writing the null hypotheses and the alternative hypothesis. I want to do that now, you try it. Try writing the null hypothesis, alternative hypothesis for each of these scenarios. A company has a medicine that's being manufactured, and the company claims on average each pill contains 14 milligrams of the active ingredient. Can a student tell me please what you put in there? I'm ready to listen.
Would it be equals?
Yes. Equal 14 milligram. This is the claim. And not equal 14 milligram. Okay, what about the next one, guys? Let's go to the next one. A school principal wants to test if it is true that the junior used a computer for school work less than 70% of the time. Too much space, we don't need that much. Okay, can you guys tell me what you put in there?
HO would be greater than or equal to, and HA would be less than.
Yeah, but what is the variable? What letter would you use? P, because it's a percent. Yes, I agree. Look, guys, I cannot emphasize how important it is to know how to write a null in the alternative. If after all the examples that I did, you're still not sure, confused, no issue. Go back, revisit my video, replay my video, or go on YouTube and just ask for introduction to hypothesis testing, stating the null, and you're gonna find tons of good videos. I'm not saying all the videos are good there, but there are many of them that are excellent as well. Number 3, an economist claims that the average price of a home in a certain area is 800,000. That's an equal sign, guys. Mean. Maybe as some students will ask, when do we know it's a mean, it's a proportion? Well, look here, it's a percent, guys, so it has to be a proportion. Here is just a number, a dollar amount. It has to be an average. 800,000, different from 800,000. And the claim happened to be in HO, I'm sorry. Number 4, guys. A researcher says that more than half of all Americans are overweight. What did you guys do here?
Greater than or equal to?
More than. More than doesn't have an equal sign. This is more than. So the complement to it will be this. But what letter do you use here? You have 3 choices, guys, in the whole book. Just 3 of them we're going to be using. So what would it be, first, second, or third?
Second?
Second, it's a proportion. Half is 50%. P, yes. And a half. Or you can put 50%. And if you want to know the claim, guys, it's right here. And the last one. At a manufacturing plant, a certain product is supposed to weigh at least 12 pounds. Okay.
Less than or equal to?
At least is this. At least is more than or equal to. So guys, it's going to be at most is less than or equal to. And since it is a number, weight, it is mean, average. So greater than goes in the first one, and less than goes in the second one. And this is 12 pounds. This is my claim, and this is 12 pounds. So guys, in summary, if this goes in HO, that one has to go in HA. No other choices. You don't have alternative. These are pairs come together. If this one goes in HO, that one has to be in HA. You don't have a choice. It's not up to us. This is how it works. If you have an equal, I think it's easy for you to tell what's going to be in HA, not equal. Any statement with HO and HA has to look like one of the three sets. It can't be anything else, guys. That's how it is. Either these two together, or the second two together, or the last two. If he says different from to begin with, don't put it in the null hypothesis, because the difference has to be in the alternative. You put the alternative and then you put the equal sign in the null hypothesis. We will demo this today, guys. You will see tons of problems doing this. All right. Now, let me go back to my handout. Okay, this one I will go over also in a little bit that relates to that. So I'm just gonna leave this for now. I'll revisit. And I wanna show you what the steps are for hypothesis test. Steps for hypothesis testing. You already practiced this. You will learn today how to do this and that using your TI-84. Making the decision is very easy. Once you get the p-value, as I said before, if the p-value is less than alpha, you reject HO, and the p-value more than alpha, you fail to reject HO. So that we should consider done, guys, because we're ready. Once we find the p-value, we can figure this out. And then I will show you guys how to address people's claim, whether you support the claim or we don't support the claim. So how do you write the conclusion for a reader, someone who doesn't know statistics? How would you interpret your decision in words in the context of the claim? We're gonna be doing that. So this is step number 1. This is step number 2. This is step number 3, 4, and 5. For the sake of practice on using the calculator, guys, I wanna have you just try to do those 3 using your calculator and tell me what kind of answers you will come up with. Eventually, you won't have to do the work by hand, but I want you to later appreciate, just how the calculator does the work in the background and give you all the answers without having you doing any tedious calculations. So can you take a minute and just give me the answer to those 3, if you have your calculator handy, please. And the answer is 2.47. So you notice, guys, the numerator enclosed within parentheses, denominator, parentheses, 12 over square root of 35, close parentheses. This is 2.47. Did anyone do number 2? Give me the answer for 2. T. What did you guys get for T? Okay, yes, -9, -0.9007. So if you do 3 decimal places, it would be 901. T is always 3. As you can see in table 5, Z is 2. What about the last one? Let's do the last one together. I'll do 0.55 minus 0.52 divided by, there is a reason why I'm asking you to do those things. These are called the test statistics, step number 2. Okay, so we got 0.55 times 0.45 divided by, we're still inside the square root, so we're still safe. 200, is that 200 here? Yeah. And now exit the square root. This is how you exit, like that. And it is -0.568. 535, etc.
Did you miss a 5?
Yeah, I think so. I did indeed. There you go. Now it's going to change. I was wondering, this answer doesn't look like what I expected. Yep, 0.8528. All right. Interpret the p-value. Cannot emphasize how important this part is, because that's going to be the deal breaker for all problems. You know the p-value, you know how to use it, you know how to solve the problem. He gives us a p-value here, and he gives us alpha, and he asks us to compare them. Well, you notice, guys, that 0.0237, which is the p-value, is less than alpha, less than 5%. Then we should what? Reject or fail to reject the null hypothesis. What's the magic word, guys? If p-value is less than alpha, okay, I'm gonna give you a chance. I know you don't probably memorize this yet, but if the p-value is less than alpha, you reject the null hypothesis. Now look at number 2. Alpha is 0.01 and the p-value is 0.0237. So look what alpha makes a big change. Well, you notice that 0.0237, guys, is bigger than alpha. So then it will be fail to reject the null hypothesis. And do not change the word fail to reject with accept. If you fail to reject something, guys, it doesn't mean that you are in acceptance. It means that you could not have enough evidence to reject, you know that, so you ended up not rejecting it. So you could, for example, you could argue with me about something, and I just give up arguing with you, and I tell you, okay, I'll do it. It doesn't mean I am in acceptance, but I just fail to reject your argument. All right. Now, the p-value, if you have a left tail test, the p-value is an area to the left of the tail. If you have a right tail test, the p-value is an area in the right of the tail. If you have a two-tail test, the p-value is on the right and on the left. You just take one area, multiply by 2, and you get the p-value. However, the calculator doesn't require that to do any steps. It will just give us the p-value and we use it as is. Let's go to page 8. Let's give you an example here. And see, this is the first exercise. We will be ready in a couple minutes. Find the p-value for a left tail hypothesis test with a test statistic of z equals -2.23. So this is the p-value, guys. I want to show you how to do it using a diagram so you can appreciate what the calculator is going to do in a second. -2.23 should be here. And since this is a left tail test, the p-value is an area to the left. Do you guys still remember from chapter 5 how to find this area? It is a normal CDF. Area to the left will be -1,000,000, -2.23, and then comma 0, comma 1. Let's see what this p-value is. You don't have to do it this way, so we're doing it. We haven't done the tests yet. I'm just going to show you how to do this. Normal CDF. So we got -1,000 or 1,000,000, it doesn't matter. -2.23, comma 0, comma 1. There you go. It's 0.0129. Okay, based on this value, guys, alpha is 0.01. What do? You reject HO or you fail to reject HO? Can someone tell me, please? Compare the p-value with alpha. This is your p-value and this is your alpha. Is the p-value bigger or smaller? Yes, bigger. So that means you fail to reject HO. Okay, let's do example 2. Watch, guys. Find the p-value for two-tail test with z is 2.14. Here is how the p-value looks like. This is 2.14. The p-value is split in halves, so there is another one at negative 2.14. Okay, all you need to find one area and multiply by 2, guys. How do you find this? It's normal CDF, 2.14, lower bound, upper bound is 1,000,000, 0.1. You can put 1,000. It's a z-score. Z-scores, if you go beyond 3, you have very unusual. Even if you can put 10 here, you would still get the same answer. So it will be second and distribute, normal CDF, 2.14, comma, 1,000, comma, 0, comma, 1. Here you go. But I have 2, so 0.0162. My p-value will be double of this because it's a two-tail test. So p-value, guys, equal 2 times 0.0162, which is, I'll do it, 0.0324. Okay, so is it less than 5? I have feedback already from a student. It's less than alpha, so you reject the null. Okay. Now, the reason why, guys, I ask you to just do a practice for the test statistics, actually, you will not be doing it by hand just like this, because the test statistic, which is step number 2, as you learned in chapter 2, the z-score is x minus the mean divided by sigma. But when we work with sample means, we change this to x bar and this to sigma over square root of n. This is called the test statistic. And if you guys notice what I put here, look, x bar minus mean sigma over square root of n. So I just wanted you to have a feel of how the test statistic is calculated. Your calculator will take care of everything, but I'm going to show you that we could do this by hand and get the same output as the calculator. So if you're ready, guys, we're ready for the first complete hypothesis testing problem. Example, let's get ready. In auto racing, a pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. So the pit crew claims that they can change replace 4 tires and refuel a race car in less than 13 seconds. That's a pretty serious claim. So if that they want to market themselves and they're claiming that they can do this in less than 13 seconds, we need to test this claim to validate it. So first of all, let's write the null and the alternative hypothesis. Would you guys agree with me that the null and the alternative should be this? That's their claim. And what would be the total opposite? The competing hypothesis will be greater than or equal to 13 seconds. So this is step number 1. A random selection of 32 pit stops, so n is 32, has a sample mean of 12.9. It is less than 13, so still on the safe side. Assume that the population standard deviation is 0.19. You see, guys, what they say? They say sigma is 0.19 seconds. So it's not S, he says population standard deviation. Why this is important? Because once he gives me sigma, it's gonna be a Z test, not a T test, just like in chapter 6. Between Z interval, T interval, exactly the same thing. So it will be a normal distribution here. Is there enough evidence to support the claim at alpha equals 0.01? So alpha is what? 0.01. Okay, I'm ready to show you the magic of the calculator here. So have your calculator handy, guys, and let's do this. You go to Stat, Tests, Z-test. Section 7.2, it's all about the Z-test because sigma is known. And it's a summary, stats. Okay. Under mu0, this is the null hypothesis. It's asking you what is the value that you're using in the null hypothesis. It's 13. We assume that the null hypothesis is true until proven otherwise. So this is the assumption that the mean is 13. Now he wants sigma, which is 0.19. Now he wants X bar, which is 12.9. Then N is 32. The next step, guys, is go to your HA and check the sign and match it right here. So if I go back to HA, guys, I see a less than, then I have to match it here. To match it, you just scroll over it and press enter. You must press enter here and then hit calculate or draw. I'm gonna do a draw here. All right. So step number 2, which is Z, equals negative 2.9, the 2 digits, guys, negative 2.98. P-value is step number 3. You see the calculator does all the tedious calculations for you. 0.0015. Okay, I'm done with the calculator. Can you guys tell me if the p-value is more than alpha or less than alpha? There is alpha. What sign do I put? So let's see, I have an input from a student. It says less than alpha, I do agree. So what's the decision? Reject null hypothesis or fail to reject the null? Reject, yes. Okay, now the last step, guys, which is for a reader, write your conclusion in words in the context of the claim. Please pay attention to this. We rejected HO. We have 2 competing hypotheses. We rejected the first one, and luckily our claim happened to be in the second one, so we support our claim because this is bad. This is bad right here. That means the second one is good, and then you support it. That's how it works. So if you reject HO or H naught or H0 and your claim happened to be in HA, you support your claim. You can write a note for this. So you write. Here's how you write it down. Not up to me. This is not my wording. This is the standard wording here. So you say there is enough evidence at what is the level of significance. We have to tell the reader that we had a 1% chance of making a type 1 error. So you have to include this language. At the 0.01 level of significance, to support the pit crew claim, that their mean pit stop time is less than 13 seconds. That's a good marketing for them. So their claim is valid. They're not lying. We were able to support their claim. All right. So these are the 5 steps, guys. This is what I'm going to be doing from now till the end of the semester, solving problems like that. Now for this one, guys, I could have done this by hand by using this formula right here. And I'm going to show you. If had I done the formula, X bar would have been what? 12.9 minus the mean. The mean is what we assume is true until proven otherwise, 13. divided by sigma, which is 0.19 over square root of 32. I'm not going to do the math, guys. You're going to get this one, negative 2.98. Now, the p-value, guys, since this is a left tail test, it's an area to the left of the z-score. So your p-value, if you want to see it, guys, it's this. This is your test statistic from step number 2 at negative 2.98. And your p-value would have been this area. If you have a right tail test, it would have been on the right. This is the p-value. You can use normal CDF to find it, which is normal CDF, negative a million, negative 2.98, comma 0, comma 1. If you do this one, guys, I can assure you you're going to get this 0.0015. You did not see any shading when I did that drawing, guys, because it's so small that you're not going to be able to see the shading. This is what the p-value is. Any questions here? I'm going to move to the next question. All right. Let's go to another example. And have your calculator handy now, guys, so you can do the same steps with me, please. According to a study, the mean cost of bariatric weight loss surgery is $21,500. You think this information is correct? So it's you're making a claim. Can you guys tell me what would be the null and the alternative hypothesis here? You think this information is incorrect. Any suggestions? What goes in here? Before you read further. Equal or not equal? Exactly. Equal 21,500 and not equal 21,500. That's what your claim. Because you think we know it's 21,500, but you're making a claim that it's not. You think it's this, not correct. So that's a claim. You randomly selected 25 surgeries and then find that the average cost is 20,695. Population standard deviation sigma is given to be 2250. And the population is normally distributed. He has to tell you that the original population is normally distributed because the sample size is less than 30. Is there enough evidence to support the claim at alpha equals 0.05? I'm gonna box it in, guys, because that's very important to use. Use a p-value, use technology. So this is gonna be the z-test again, guys. And if you ask me why the z-test, because sigma is giving. Okay, let's run the test. So it's a matter, guys, of knowing what you have, the information that this is n, this is x bar, this is sigma, and just plug it in. I know it's not as simple as I'm saying because you need to know what's given to you, but once you do that, it's very straightforward. Z-test. Okay. So we're testing against 21,500. Sigma is 2250, guys. X bar 2695. N is 25. And the alternative hypothesis has not equal sign. And I'm gonna hit a draw. So you can see the p-value. You see, it's a two-tail test, guys. The p-value is on both sides. They're exactly the same. If you pick up the area on one side, multiply by 2, you get 0.0736. That's what he gave us. So Z will be negative 1.79. And p-value is 0.0736. And I'm done with the calculator. I'll put it on the side. I don't need it anymore. Okay, guys, what's the decision? More than alpha or less than alpha?
More.
More. Good. So we failed to reject HO. Okay, conclusion. Let's see the scenario here. How do you write your conclusion? You fail to reject HO. So you're saying probably the HO is good. I cannot reject it. Do you think, guys, you can still support your claim? Yes or no? We cannot reject HO, and our claim happened to be not in HO and HA. No, we cannot support the claim. Exactly. So if you fail to reject, and take a note of this, guys, I'm going to summarize those and email them to you in a paragraph. But if you fail to reject the null hypothesis and your claim is in the alternative, you cannot support the claim. Because you're saying that probably HO is good, probably it is true, I cannot reject it. That means you cannot support the competing hypothesis. You can support either one or the other, but not both, guys. Cannot say it's both, that's impossible. Rain or no rain, can't be both. So you're right, there is not enough evidence at the 0.05 level of significance to support the claim that the mean cost of surgery is different from 21,500. All right. Now, this is another way to solve problems using critical value approach, but I'm going to focus on the p-value. So I'd like you not just to discard this for now. I might consider it later. I might just have you only do it with the p-value approach. So let's just continue with the p-value because I want you to master this concept first. So we're going to do another example right here, guys. Employees at a construction and mining company claim that the mean salary of the company mechanical engineer is less than that of the one of its competitors, which is 68,000. Can a student help me state the null and the alternative here? What are they claiming? They're saying that their mean average salary is less than their competitor, which is 68,000. So can you guys tell me what goes in the null and what goes in the alternative? Yes. Try, I will support you if you make mistake. Yep, you are correct. So less than 68,000 right here and greater than or equal 68,000. That's their claim. You make a claim, guys, you better be able to support it. Let's see if those engineers have enough evidence to support their claim. A random sample of 20 employees, 20 engineers, has a mean salary of 66,900. Yeah, that is less than 68,000. Assume that sigma is 5,500. And the population is normally distributed. He has to tell you population is normally distributed because the sample size is less than 30. At alpha equals 0.05, test the claim. Okay, z-test. And why again? Because sigma is giving. Okay, let's go. Watch, guys. Stat, z-test. Okay, we're competing against the value 68,000. That's cutoff value. And 5,500 is the standard deviation. And what do I have? 66,900. And we have 20 engineers. And what is the alternative sign, guys? It's less than. And let's do a draw, if you like. Oh, it's a huge p-value. It's going to be big. So Z is negative 0.89. And look at the p-value, guys. It's 0.1855. That's substantial. What's your decision? Can you help me make the decision, please, to reject HO or fail to reject HO? You stay, when I ask you explain your reasoning, you do it like equals 0.1855, and this is alpha. Is it bigger or smaller? Bigger, correct? And what would that mean? Fail to reject HO. For students who tell me that it's a little bit hard for me to memorize this, I tell them try to memorize this one. P-value low, HO must go. Meaning, if the p-value is small, you reject the null. So fail to reject HO. And now, guys, let's write the conclusion. That's the important part. For a reader, they just want a conclusion. The manager or the boss, he wants to know whether their claim is valid or not. Well, since we cannot reject the null hypothesis, and unfortunately their claim was in the alternative, we cannot support their claim. So we say there is not enough evidence at the 0.05 level of significance to support the employee's claim that what? They make less than their competitor, which is 68,000. So their claim is not valid, and I don't think their boss is going to do anything about it because they could not support their claim. This is how important hypothesis testing. And now with COVID-19 and companies are rushing, to create a vaccination, why it's going to take so much time, guys? Because they have to run the hypothesis test. And the hypothesis test is not going to involve only 20 employees. It's going to involve tens of thousands of patients. And that's why it's going to take time. But what they're going to present to the FDA at the very end in order to approve or disapprove of the vaccine, it is the hypothesis test. So I don't want you to take lightly what you're learning. It's a very important stuff, guys, but we're doing it at a very small scale here with small data sets. But in real life, they use very large data sets, to perform hypothesis tests. The employees make less than 68,000. So their claim is not valid. It doesn't mean that they're making a lot more. It's just the sample that they used did not show that they can support their claim. Okay. Now, guys, I'm going to go to another handout and continue with this section. This is the one that I told you I sent via email just shortly. So let me just get to this one. Okay. So again, in the second handout, I stated, just steps. Step number 1, state the null and the alternative hypothesis and identify the claim. Step number 2, calculate the standardized test statistic, which is Z when sigma is known. Step 3, calculate the p-value or the critical value, but I'm just focusing on the p-value today. Make a decision to reject HO or fail to reject HO based on the p-value or critical value, and write your conclusion in words in terms of the claim. This is an example that I would like you to do on your own because I provided so much details, but I'm going to go to the next example and continue with this. Right here. One more question from 7.2 and we'll go to 7.3, guys. And you're gonna see the transition. It's gonna be very smooth. The EPA reports that exhaust emission for a certain car model has a normal distribution with the mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. So you see, it says population standard deviation. This is a hint for you guys. It's a z-test. So sigma is 0.4. The car manufacturer claims, now after the claim, this is where you're gonna use to write your claim. Their new process reduces the mean level of exhaust emitted for this car model. Can you guys tell me what the claim is? We know that exhaust emission usually are 1.45. A car manufacturer claims that their new process reduces the exhaust emitted for this car model. What would be the null and the alternative? Let me see what students are saying here. Less than, yes, that is correct. They're claiming that they can do better with less than 1.45. Very good. That's the claim. And this is the competing hypothesis. Okay. Claims, okay. A simple random sample of 31 cars, that's 31, is taken. The mean level of exhaust emitted for this sample, X bar, is 1.21. And we need to test that alpha equals 0.01, guys. Okay, let's run the z-test and we're all set here. Turn the calculator on, stat, tests, z-test. No data yet. Okay, we're testing against 1.45. Sigma is 0.4, as you noticed. X bar is 1.21, guys. And N is 31. And what's the sign? Less than. You always select it and press enter, guys. Look what I'm doing here just to show you. I selected and press enter. Make sure it is properly selected. Let's hit calculate this time. It's faster, actually. So Z is negative 3.34. And the p-value, let me just show it to you. It says, I'm gonna just copy it. I'll write it down, guys. Please do not ignore the -4. When you see a negative here, it means it's almost 0. A -4 means move the decimal point 4 digits to the left. So this will be 0.000417955. With 4 decimal places, you can write it 0.0004. Very small. So if it is very small, it's less than alpha, guys, for sure. So the decision will be what? To reject the null hypothesis. Okay. We reject the null hypothesis. We're saying this is bad. And luckily the claim happened to be in HA. So the claim is good. We support the claim. That's as simple as that. So we say there is enough evidence at the 0.01 level of significance to support the claim by the car manufacturer. And you can write it down. When you do your work online, it's not going to ask you to type the claim. You just select it from a drop-down menu, which is, it says that the new process reduces the mean level of exhaust emitted. That is the claim, guys, right here. All right. So this is section 7.2. Now we're gonna take you to section 7.3, and you're gonna see the difference is instead of using the Z distribution, we'll be using the T distribution. You can see sigma, this is section 7.3. Sigma not known means S is given instead. All right. Let's do this exercise and show you how we can continue, just doing the problems without any interruption. The amount of water consumed per week by Montana residents is normally distributed with an unknown mean. A simple random sample of 26 residents, N is 26, has a mean of 120.3 gallons. So X bar is 120.3 gallons. And a standard deviation of 10 gallons. So S is 10. The city of Bosman claims, now guys, you follow this wording to write your null and the alternative hypothesis, that the average water consumed in the state of Montana is not 125 gallons. So can you guys help me write the null and the alternative? What would that be? They claim that the average consumption of water is not 125. So what would that be? Equal or not equal? Yes. Not equal, 125, and equal. And the claim, guys, if you agree with me, it is HA. Why? Because they say not 125, and this is not 125, different from 125. Okay. What kind of test do we use here? Because S is given, guys, instead of sigma, your Z test, it changes to a T test. So it is a T test. T test, and I put Y because S is given instead of sigma. This is the popular case, guys, the T test. Now, guys, if you remember the formula that I put previously, it was this, sigma over square root of n. It will be the same, but instead of sigma, we'll just put S over square root of n. But again, guys, we're not going to do this by hand. We're going to show you how this could be done using the calculator. So if you're ready, watch. On stat. I'm done with number one, guys. No more. I'm going to number two now. T-test. Stats. Okay. What is the value and the null hypothesis? We assume it is 125 until proven otherwise. X bar is 120.3. Is it 0.3? Yes. And S, you see, it doesn't prompt you to enter sigma. It prompts you to enter S now, which we say is 10 gallons. And N is 26. And not equal, guys. Let me do a draw if you like. It's a two-tail test. If the p-value shows on both sides and there's so much of it, it will be big, so you fail to reject the null hypothesis. Oh, it's not too big. Let me see. Okay. The p-value is 0.0244 and t is negative 2.3965. Let me write them down. 65 is 3 decimal places, so 397, guys. And the p-value is 0.0244. If you want to show the p-value, guys, this is the p-value right here. It's on both sides. This is t equal negative 2.397, and this is the negative 2.397. That's the p-value. Okay. Is the p-value more than alpha or less than alpha? He says use a 0.01 level of significance. I think, guys, you should agree with me that the p-value is more than alpha. So we fail to reject HO. Can someone tell me what the conclusion is? We cannot reject HO. So we're saying HO probably good. Probably it's not bad. And the claim happened to be in HA. How do I start my conclusion here? You always start with there is not enough evidence. Very good, Allah. At the 0.01 level of significance. I want you guys to know something. I could give you this problem on the test with those steps, but instead of 1%, I change it to 5%. Everything is going to change. If I change the 1% to 5%, then 0.0244 is going to be less than alpha. And then you're going to reject HO and support the claim. So you see how important alpha is. It makes a big difference. Level of significance to support the claim that the mean consumption of water is different from 125 gallons. So probably their claim is not valid. We could not support it. Next question. Number 3. Again, it's t-test, guys. A credit card company wondered whether given frequent flyer miles for every purchase would increase their card usage. So they want people to use their credit card more often, which has a current mean use of $2,500 per year. So on average, people use their credit cards for about $2,500 a year. They gave free miles to a simple random sample of 24 credit, so that's N, customers, and found the sample mean to be X bar 2542. You see, with the sample standard deviation, you cannot go wrong and put sigma here, guys. It's S. S is 109. Can you guys tell me what's the null and the alternative hypothesis here? What is it the company is trying to prove? They say they wanted to increase the credit card usage. How would you state the null and the alternative hypothesis? Mean and mean. It's all about the mean in section 7.2 and 7.3. Can a student suggest statements? What does the word increase mean? Greater, no, not greater than or equal to. Increase it from 2,500, it's greater than 2,500, no equal. If you want to use equal, he will say at least. But he says increase, you have to go beyond this one, so it will be greater than 2,500. And that's the claim, guys. Mean less than $2,500. All right. It's a t-test, guys, because S is giving. And step number 2 and 3 are going to be done on the calculator. So let's do it together. Turn the calculator on. Stat. Tests. T-test. U0. We're testing against the $2,500 amount. Okay. What did we have here? 2542. S is 109. N, how many credit card members? 24. And we're testing that it is greater, the alternative is greater than. Okay, let's do a draw, guys, if you like to see the p-value in action. Okay, nothing yet. Watch. Okay, let's see how big this p-value is. So T is 1.888. And p-value, guys, is 0.0359. Any questions, please ask, guys. And then what's the decision? (0.359). Do you guys agree with me? It's bigger than alpha because he gave me 0.01. So we fail to reject the null hypothesis. Fail to reject HO. Conclusion. E. We fail to reject the null hypothesis, and the claim happened to be in the alternative, so we cannot support the claim. So the fail to is linked to the word not. There is not enough evidence at the 0.01 level of significance to support the credit card company's claim. So guys, let me ask you a question. Should they continue offering the frequent miles, or they should discontinue that? What do you guys think? Probably another question will pop up as you do this problem. Should they stop their frequent flyer miles? Yes or no? Yes, they should stop it because we cannot support the claim that it's making any good for them. That's how important hypothesis testing is. Okay, next one. Number 4. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. Okay, they claim if you go and wait in line, it's going to be less than 3.5 minutes. Well, we need to test this claim. So we pick a random sample of 15 customers, so that's N. And we found out that they have a mean of 3.4, so X bar is 3.4, guys, with a standard deviation of 0.6, so S is 0.6. At alpha equals 0.05, test the fast food outlet's claim using not confidence interval p-value. Just without this, let's remove this. Assume that the population is normally distributed, use the TI-84. Okay, you're ready, guys, to see how this is done? Step number 1, state the null and the alternative hypotheses. They think that they can do in less than 3.5 minutes. That's their claim. And that's the null hypothesis will be mean is greater than or equal to 3.5 minutes. Okay, again, guys, this is a t-test. Okay, what do we have for the t-test? We have X bar. Let me just write them down for you. And if you have your calculator, guys, please start entering the data in there. And N is 15. And we don't want alpha to be 0.05. Okay, watch. Stat t-test. All right, we're testing against 3.5 minutes. So we assume it is 3.5 to begin with. Oh, 35. X bar is 3.4. That's a little bit less than 3.5. But S is big. What was S? 0.6 minutes. N is 15. And let's see if the food outlet has a valid claim, guys. I'm curious to know. It's less than. And then hit to draw. Oh, it's a huge p-value. Then you're going to fail to reject HO. T is negative 0.646. And p-value is 0. Let me write it down, guys. Oh, it's too huge, too big. All right. So what's the decision, guys? Can you help me, please? Reject or fail to reject HO? Fail to reject HO. And when you do your homework online, if it asks you why, you select because the p-value is greater than alpha. That's why. This is bigger than alpha, guys, which is 0.05. Conclusion. Interpret your decision in the context of the claim. Every time you do a fail to, you have to start with there is not enough evidence at the 0.05 level of significance to support the food outlets claim. So probably they're lying, guys. If they insist that their claim is valid, you tell them that they have to pick another sample and see if that would validate, just their claim. But with this sample, we could not support their claim. Any questions? For the next one, let me see how much time we have. Okay, still have time. For the next one, guys, I'm gonna pause for a couple minutes until you key in the data and put it in L1. So 2 minutes, put your data in L1. Resume recording. Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. But Consumer Advocate magazine ran tests of 10 randomly selected cigarettes and found the amounts. And they gave us the amounts. It is a serious matter to charge that the company advertising is wrong. So the magazine editor chooses a significance level of alpha equals 0.01. Now here's the question, guys. Can the editor prove that the mean nicotine level is greater than 40 milligrams? It's straightforward. He's asking you to test the claim that the mean nicotine level is greater than 40 milligrams. And this one will be less than or equal. See, they come in pairs together. Okay, this is a t-test, guys. When he gives you a raw data set, it is a t-test, simply a t-test. But for input, instead of stats, you use data. You select data. So let's run the test. I already have my data in there. And watch, guys. Stat, t-test, data. Okay, what we're testing against, what's the value? 40 milligrams. So we just put 40. If you put your data in L1, keep it L1, guys. I did in L1, 1. And we're testing that the mean. We're not testing the cigarettes company claim. We're testing the editor's claim because that's what the question is about. If we were testing the company's claim, they say it's at most 40. It would have been in the null hypothesis, but we have the magazine editor question there. So they think it is more than 40, which is pretty serious accusation, guys. So let's see if the magazine is correct. Let's do a draw. Okay. So the test statistic, let me just double check and have the data in there correctly. Yeah, that's my data. So again, show you the t-test. Theta 40, L1, mean is greater than 40. Then you can do a calculate or a draw, it's up to you. Small p-value, as you can see. 2.746, t-test 2.746, and the p-value will be 0.0113. Alpha is 0.01 right here. So p-value is more than alpha, guys. So we fail to reject HO. And what is the conclusion? Interpret your decision in the context of the claim. There is not enough evidence at the 0.01 level of significance to support the editor's claim that the amount of nicotine is more than 40 milligrams. That magazine can get in trouble because of this, because they're making a claim that they could not verify. So actually the Carolina Tobacco Company can go back and sue them. But they could pick a different sample and they might be successful in that case. But with this sample, guys, there is no proof that the companies is putting an average more than 4 milligram of nicotine in its cigarettes. So this is another example of the t-test. What I'm gonna do, I'm just gonna do one more example, guys, but this is gonna be about the proportion, just to give you a feel of the proportion, and we'll continue working on that on Tuesday of next week. So testing a claim about the population proportion. You're gonna see it's a very easy test, but it's not about the mean, it's about the proportion. So let's see what this exercise is. And the engineering school at a major university claims that 20% of its graduates are women. In a graduating class of 210 students, 46 were women. Does this suggest that the school is believable? Use alpha equals 0.05. Can a student help me put the null in the alternative? They say that 20% of their graduates are women. Well, how would you state those, guys? I know how to do it myself. I need some participation, please. What would it be?
E.
P. And then
Equals.
what? Equals, exactly. 20% and not equal 20%. And this is the claim. So we want to check if the claim is valid, guys, then the school is believable. If the claim is not valid, the school is not believable. Okay. When you do a test for the proportion, you don't run a z-test and t-test. They're reserved for the mean. You run what we call the proportion z-test. And the proportion z-test, guys, requires only two values from you. The number of observations and the number of successes, which are given to us. N is 210, and X, just like in confidence interval, guys, one prop Z interval, you need X and N, it's exactly the same thing. And we have alpha here for the p-value later. Okay, let me show you how to run this test. Stat, tests. Okay, I'm gonna move this bar so I can see what I'm doing. Okay, watch, it's number 5, guys. P0, You see, it was mu 0 before, now p0 because we're working with the proportion. You have to put the value that we assume it is true until proven otherwise. So 20%, to change it to a decimal, guys, it's 0.2. I don't know if you put 20, they would accept it. I don't remember if it recognizes this as 20%, but always change to a decimal, guys. Okay, x is a smaller value. So x is 46. N is 210. And we're testing different from, you see, no changes, guys. Everything the same. And then you want to do a draw. Let me do a draw. Oh, huge p-value. Z is 0.69. Let me write it down. And the p-value, guys, is, you can see it. Let me show it to you again. It's a huge. You have big p-value, you fail to reject HO, guys. 0.4902. And if you want to see the p-value in action, this is what the p-value looks like. And the z is 0.69, so this is 0.69. That will be a negative 0.69. And your p-value is the area on both sides. That's the p-value. So if you guys do normal CDF on 0.69, find the area to the right, multiply by 2, I can assure you're going to get this answer exactly, 0.4902. Okay. Would you guys agree with me that the p-value is more than alpha? So the decision is what? Fail to reject HO. I want one student to tell me how do we write the conclusion here. The claim is in HO, and we fail to reject HO. Any guesses? What do you think we should say? I'll start. There is not. Fail is not. Any suggestions, guys? I want to pause the recording. Okay, so just go back 1 second because I paused the recording here. So again, for this one, guys, we ended up with the test statistic of 0.69, a p-value of 0.4902. Because the p-value was more than alpha, we decided to fail to reject the null hypothesis. And because the claim is in the null hypothesis, the language we should use is there is not enough evidence to reject the claim by the school. And because the claim is in the null hypothesis and we did not reject it, so the school is probably believable. So this is how we state the conclusion when the claim is in the null hypothesis. In conclusion, guys, here is what you say in each case. You guys can cut a portion here, keep it handy to use it because this is going to help you a lot. If I want to do backwards because we did those early. If the claim is in HA and you reject HO, you state that there is enough evidence to support the claim at the level of significance. That does not change, guys, from one problem to another. Next, if the claim is in HA and you fail to reject HO, you remember we say that there is not enough evidence to support the claim. Now, if the claim is in HO and you fail to reject HO, that's what happened today, just now, a few minutes ago. You state that there is not enough evidence to reject the claim. There's fourth scenario, guys, and there are no other scenarios ever. These are the only 4 scenarios. If your claim is in HO and you reject HO, you state that there is enough evidence to reject the claim. To reject the claim. All right. So these are the 4 possibilities, guys, that you have to use in step number 5 always. I would just make sure that they are handy as I do the homework online and that and anything else, because you have to choose one of those scenarios. And don't forget, guys, you have to put at the alpha level of significance always. Let me stop this and make an announcement before you're done.